Well, these are the two last examples about factoring polynomials. We are going to start with P3 of x, rewriting the polynomial 20x to the fifth power minus 30x to the fourth minus 10x cubed minus 20x squared. And in this case, we can take out 10x squared out. So the result is 2x to the third power minus 3x squared minus x minus 2. This is a product equals to 0, which means that x squared must be 0, or the polynomial 2x cubed minus 3x squared minus x minus 2 must be 0. X squared equals 0 means that we have a double root x equals 0. And regarding the polynomial, we don't have a special product nor a biquadratic equation. So go ahead with the Ruffini's method. So 2, -3, -1, and -2. The root candidates are the divisors of 2. So it could be plus -1 or plus -2. And if we check the easy rules for the positive and -1, we realize that the addition of all the coefficients is not 0, so 1 is not a root of my polynomial, and the additions of every other number, 2 minus 1 is 1, and -3 minus 2 is -5. They are not the same, so -1 is also not a root of my polynomial. We are going to try then with 2. 2 times 2 is 4, minus 3 is 1, times 2 is 2, minus 1 is 1, times 2 is 2, minus 2 is 0, so it works. The quadratic equation that I obtain is 2x squared plus x plus 1 equals to 0. And when I solve it, I have -1 plus minus the square root of 1 minus 4 times 2 times 1, which is 8, over 2 times 2, 4. But the number that is inside the root is a negative number, which implies that this number is not a real number. We don't get any root from the quadratic equation. Therefore, for this fifth degree polynomial, we have only 3 roots. One of them is a double root, 0, and the other one comes from the Ruffini's method, which is the 2. When I factor the polynomial P3 of x, which is 20x to the fifth power minus 30x to the fourth minus 10x cubed minus 20x squared, and I write the factors, I have x squared, obviously, and x minus 2. But when we do the multiplication and check the degree of the polynomial, we obtain x squared times x, which is x cubed, and not to the fifth power. And this is because we are missing this polynomial, which has no roots. So we need to add the factor 2x squared plus x plus 1. And now check again. So do we have the same degree? Yes, x squared, x and x squared, we have x to the fifth power. Do we have the same leading coefficient? So 1 times 1 times 2 is 2, but we have 20. So we need to add a 10 in front of the expression. And it's done. This is the solution. Let's go with the last one. We write the corresponding equation to this polynomial. And we realize that, yes, in this case we have a special product. We have x squared plus 1 times x squared minus 1. A product equals to 0, which means that x squared plus 1 must be 0, or x squared minus 1 must be 0. If we solve these two second-degree equations, we obtain x equals positive negative square root of -1, which is not a real number. So here we don't have roots, exactly the same as on the other exercise. If we solve the other one, we get plus negative square root of 1, which is plus negative 1, 2 roots. This quadratic equation could be solved as well using special products, because x squared minus 1 is x plus 1 times x minus 1, which is its decomposition. And here we are, the corresponding roots. But we are going to write it down properly. The roots of this 4-degree polynomial are negative 1 and positive 1. Only 2 roots for a 4th-degree polynomial. When I do the decomposition of x to the 4th power minus 1, and I consider its roots, I have x plus 1 times x minus 1. But this product is a 2nd-degree polynomial, not a 4th-degree polynomial. And this is because we are missing the polynomial with no roots. So we need to add it at the end, and then when we check the product, we obtain the same degree, 1, 2, 3, 4, x. So x to the 4th power, and also the leading coefficient, which is 1. So we're done. This is our solution. The roots and the decomposition of our polynomial. To sum up, with these 2 exercises, we've learned that they are polynomials with no roots in the real number set, and that they will be part of the decomposition of the main polynomial. So that's all. Now it's your turn. Enjoy practicing and factoring polynomials. Bye.